Hello, everybody. I welcome you to the EDUCATOR YouTube channel, and this is our chemistry section again. I'm Rashan Samarikrama. Today, our topic will be on the main topic of the phases of matter. As if you could remember, last time under this topic, we discussed about the structure and the other properties, common properties of solids. So this time, our contents would be about the liquid, its properties and structures. So starting off, we are gonna go ahead with the properties of liquid. Again, like in solids, we are gonna discuss about statements and reasons why these properties are common for all solids, all liquids. Moving on, our first statement: a liquid has a definite volume. So, providing a reason for this statement to prove to you that this is a key property within the liquids that are present in the world. The reason is that the intermolecular force of attraction is just strong enough to confine the molecules in a definite shape, definite space. So what does this mean? As you know, in solids, the intermolecular force of attraction was the strongest. But when it comes to liquid, you understood that the intermolecular force of you can understand that the intermolecular force of attraction is just a little bit lower than the intermolecular force of attraction in solid. Yet, this intermolecular force of attraction in the liquid is still strong enough to hold it to have a definite volume within a container. You cannot keep the liquids out without a container, without a barrier on an outer object, because it tends to flow. That flowing is occurring because the intermolecular force of attraction is a little bit lower than the solid, and the space between the particles are a little bit higher than in the solids. So you know that solids have a definite shape and a definite volume, but the liquid tend to take the shape of the container, and that will be explained in the properties later on. So it takes the shape of the space that it is put into: a jug, a bottle, or a cube. So moving on to the next property. It states that a liquid has no definite shape and acquires the shape of the container. As I explained, the intermolecular force of attraction is weaker within the solid molecules, but the molecular speed is greater in a liquid than in a solid. I explained that when it came to solids, that the solid cannot move from a point 0 to a point 1 unless a force acts on it. But this is different in a liquid. Without a force acting on it, the liquid can flow. That is because the intermolecular force of attraction is weaker and the particles cannot be held together when it is compared with a solid. Then the effect of this attraction confine the molecule, whereas the effect of speed makes the molecules fly apart. So what does this explain is that the speed of the molecules, the effect of speed on the molecules, make them move over each other, go passing each other. That is the reason why you can see when you keep a liquid on a flat surface, they flow. That is because the molecules or the particles that make the phase of solid, they go past each other. They have the ability to go past each other, past each other molecules. So they could flow from point 0 to a point 1. Then the next reason is the combined effect of the two factors is that the liquid has a surface depending on the container. As I explained, if you put the liquid into a bottle, the liquid takes the shape of a bottle. If you put the liquid into a cube, like a cube in the sense a cube container, then the liquid takes the shape of that container. If you just keep it on a flat surface, it doesn't have a specific shape. It tends to the molecules tend to go past each other and flow from the point where you drop the water molecule to another point where it eventually will be stopped by a barrier, or won't stop and go on and on until it's stopped by a barrier. As again reminding you, the intermolecular force of attraction is weaker, but the molecular speed is great in a liquid than in a solid. So in a solid, the speed is weaker. That's why the solid does not move, as I told, from point 0 to point 1. Then the effect of attraction confines the molecules, whereas the effect of speed makes the molecules fly apart. The molecules go passing each other because of the effect of the speed on the molecules. And then the combined effect of these two factors in such that a liquid has a surface which depends on the shape of the container. That means that the liquid takes the shape of the container on which it is put into. Our next statement. A liquid is compressible. If you can remember, in solids, I said solids cannot be compressed any further because solids are known as the condensed phase by scientists. Scientists call solids the last phase of compression or the last phase of condensation, meaning that it cannot be squashed anymore. But on the other hand, a liquid is compressible. The reason for this is that the distance between the neighboring molecules is larger in a liquid, sorry. The distance between each molecules in a liquid is very much larger than when compared to a solid. I explained that the particles are close to each other and they are in a sequential arrangement. But on the other hand, on a liquid, the size or the distance between one molecule and the other molecule is just wide. So then that is the reason why liquids can be compressed, because the space between the molecules is larger, and so the molecules could be brought together. They have a more space so that they could be brought together by compressing them to form the state of solid. So under that, we can prove that a liquid is compressible, another property of the liquid. Then moving on, our next property, a liquid can diffuse into another liquid, but this is much slower when it is compared to gases. On this case, our reason would be because the molecules move faster in a liquid than in a solid, but slower as compared to the molecules of gas. So what does this mean? So in a solid, I stated that a solid cannot diffuse into another solid easily, or it can never. I would like to use that term to explain to you easily this how this diffusion happens in a liquid more than in a solid and less than in a gas. The solid, I will explain, can never diffuse into can never, in the sense, cannot diffuse into another solid. But this liquid can diffuse into another liquid. According to this statement, a liquid can diffuse into another liquid, but the process is much slower. The reason for this is that the energy or the molecular space between the atoms of a liquid is lesser than that of gas, whereas in the gas the molecules are far apart from each other. They have a huge gap between the molecules, so it's easier for a gas to diffuse into another gas. But then in liquids also they can, because there is some distance between the particles, so they can diffuse into another liquid, but this process is slower than the gases could be, because the gases have a huge space. Having explained that, moving on to the next statement, our last property, a liquid on heating changes into the gaseous state. The reason for this is that heating increases the intermolecular separation of the liquid molecules, but decreases their intermolecular force of attraction. On cooling, vapors lose heat and are converted into liquid. So this is rather confusing, the way the point is stated. So I would like to explain it to you that if you can remember, solids on heating changes to a liquid. So the liquid on heating also, their intermolecular force of separation increases while the intermolecular force of attraction decreases. So the force that attracts the molecules at some distance, the force that attracts the molecules decreases. That means the molecules fly past each other, having a huge gap. So this is eventually called the intermolecular force of separations increasing. So the distance between the molecules, that we take, for example, that was 5 centimeters, would have now become 20 centimeters, or 10 centimeters or 15 centimeters. It has increased. But the gas on cooling, the vapors, we call them water vapor. If it's water, we call them water vapor. So the vapor on cooling loses their heat. And then the space that was gained by the molecules are lost and they come into the liquid state again, having that 5 centimeter that I took for an example. So I think we have by now completed the properties, the common properties of all liquids. Yet we have another topic left, and that is the structure of the liquid. And first of all, in the structure, I would like to discuss about the arrangements of the particles of a liquid. So our first note is liquids consist of particles that are close together with no set arrangement. They can flow easily, can take shape of any container it occupies, and cannot be compressed easily. So in the properties, you learn that a liquid can be compressed, but it never said a liquid can be easily compressed. Now here it is proved that a liquid cannot be compressed easily. It is rather hard, but can be compressed. You should remember in mind that a liquid can be compressed, but it is rather hard than when it is compared with gases. And then the first statement says to us that a liquid consists of particles that are close together with no set arrangement. Now in solids, if you can remember, it was a sequential arrangement where all the molecules have the similar distance between each other. But when it comes to liquids, they don't have the similar distance. Between molecules 1 and 2, it could be 5 centimeters. Between molecules 10 and 9, it could be around 10, 7, somewhere around that, or it may be more. I don't know. I just took for an example. So that's what this statement explains. And then again, in the properties, we explain that the liquid can take the shape of the container it is put into. I said if it's put into a cube container, then it takes the shape of a cube. If it's put to a bottle, it takes the shape of a bottle. That is what is explained there. And again, most of the properties are taken into arrangements. And then it says that the liquid can flow easily. I said that's because their speed, the effect of speed on the molecules is higher when compared to solids, but is lower when compared to gases. But yet the liquids have the ability for the molecules to pass each other and then moving from a point 0 to a point 1 if kept on a surface. Then our next slide, it shows that liquids are similar to solids, that their particles are packed tight enough that they cannot be compressed furthermore. Well, explaining this, however, I would like to say that the compressing furthermore, in the sense the liquids are similar to solids, it says that the particles are a little bit tightly packed. I said earlier, I said that it could be compressed, but I explained that it's not easy to compress this when compared to gases. So this compressing furthermore, in the sense, it would mean that it is not easy. It's rather a hard process, and tightly packed in the sense they have they also have a lower distance between the atoms rather than the gases. When compared to gases, they have a lower space, but it is higher. They have a higher space between molecules when compared to a solid, because I said solids are in a sequence packaging, but then when it comes to liquids, it's not in a sequential packaging. This slide explains that there is no set arrangement. If you can see, it says the particles that are consist of particles that are close together with no set arrangement. That is what is explained as packed tight enough. That means not tightly, but just a little bit tight, that it is hard for it to be compressed. Moving on to our next slide, it also states that a liquid has an arrangement of particles that are close together, but are free to move because the force of attraction between the particles is weaker. So this again explains about another property that we discussed in the liquids or particles. They can move freely. They are not fixed and rigid and can move freely past each other. That is because the liquids contain particles that are spread out and change shape depending on the container. A liquid has an arrangement of particles that are close together but are free to move because their force of attraction, the intermolecular force of attraction, is weaker between the particles, and also they have a considerable amount of force, intermolecular force of separation, which means a liquid is said to have a short range order, which means that the arrangement of particles only repeats itself for a small number of particles. That means that their sequential arrangement. Here it is stated, the note that I just read, a liquid is said to have short range order, which means that the arrangement of particles only repeat itself for a small number of particles. This explains that if say particle 1, 2, 3, 4, 5, those 5 could have 2 centimeter or 2 not centimeters. I would take 2 millimeters apart. They are 2 millimeters apart, but the 6, 7, 8, 9, 10 won't be 2 millimeters apart. It will be some other number. Again, say 11 and 12 will be 1 millimeter apart, but 13 and 14 could be just 0 point something millimeter apart. So it's not sequence. Like if it's in a solid, if it's 2 millimeters, then all the particles have to be apart in 2 millimeters. That's what solid rigid structure of a solid explains. They are sequential arrangement, but it's different when it comes to liquids. Only the arrangement of particles only repeats itself for a small number of particles. In the sense, the sequential arrangement only is repeated for a small number of particles, not all the particles as in the solids. So the liquids, the properties of the liquid and the structure of liquid ends there. I hope this video meant something, explained to you something, and you learned something. So if you haven't yet subscribed to our channel, you can right now click on the subscription button to the educator, so that and also you can switch on notifications by clicking on the bell, so that you would get all the videos that we post rightly to your fingertips, so you can watch easily. You can watch the other part of the video, the part 3 video for the phases of matter, part 3 video for the gas. I have explained the gases very clearly, its properties and the structure. Hope to see you in the next video. Thank you.